Hey, it's Mrs. McMahon, and today we're talking about scientific notation. So if you can open to these two sheets of paper, if you don't have them, please go get them from the front of the room, and we will be ready to start. Okay, I'm making this as a video, so if there's ever a time that you need extra time, you just hit the pause button, and you can come back to it as many times as you'd like. Okay, let's first talk about scientific notation because it is a compact way of writing very large or very small numbers. Scientific notation is a compact way of writing very large or very small numbers. A number written in scientific notation has the form of a times 10 to the nth power, where 1 is less than or equal to a, which has to be less than 10. And I'm going to show you what that means in just a second. Okay, so when you are converting to scientific notation, step 1 is you're going to move the decimal to the new number in between 1 and a number up to 10. Then you're going to write using a power of 10. The exponent matches the number of times the decimal was moved. So if the decimal was moved to the left, the exponent is going to be positive. If the decimal was moved to the right, the exponent is going to be negative. Okay, we're going to probably refer back to this a couple of times, so this is very important for you to understand. Now, if you need more time, hit pause, but I'm moving on. Okay, so let's take a few of these and go over them so that you can understand how it works. So here we have 540. This is not a huge number, but I'm going to start small so that you understand. So here we have 540, but we have to look at the first two digits. Okay, this is a 5. It's bigger than 0. And this is a 4, which is less than 10. Okay, so we are going to start here at the end. This is where the hidden decimal is. If there isn't one, there's always one at the end. And you want to move it over here. So in order to move it, you have to also figure out how many spaces that is, because that's going to be your exponent. So here we would have 5 and 4/10 times 10 to the second, because we moved it 2 places to get between the 5 and the 4. Okay, so the next one, we're going to have 937 or 937,000. And this also is not that hard of a number to say. But anyway, the purpose is what we want to do is we want to get it right here between the first two digits that is greater than 0 and less than 10. Okay, so here we have our silent decimal, because if there isn't one, we make one. And it's going to go 1, 2, 3, 4, 5 times to get where we need it to be. So that 5 is what is going to be our exponent. So we are going to then have 9 and 37/100 times 10 to the 5th power. Now, this next number is why we have this. Okay, this is 1,852,000. So a lot of times you will hear people who have won the lottery and they've won $5.2 million. Okay, this is what that means. This is when we use it, when it's really big numbers. Okay, so remember we want to get it here between the 1 and the 8. And so we start at the end. And how many times do we have to go over? 1, 2, 3, 4, 5, 6. So 6 is going to be our exponent. Now we keep all of the numbers between 1 and 9. So we have 1 and 852,000 times 10 to the 6th power. Now I'd like for you to try 4 and 5 on your own. So hit pause and you try those on your own, see if you can get it, and then reveal the answer to make sure that you got it right. Okay, how did you do? If you didn't get that right, see if you can figure out what you did wrong, and then make a note and we will go over it. Okay, number 6 is a whole different kind of ball game. So here we have a decimal, and we want to make it so that it is not a decimal. And so what we're going to do is kind of the same concept. We're taking it at the decimal. We want it between the first two whole digits. So that was going to be between our 9 and our 8. So we're going to go 1, 2, 3 times, but that 3 is going to be what kind of an exponent? If you look up what we talked about before, it's going to be a negative exponent. So we write 9 and 82 hundredths times 10 to the negative 3. All right, let's try that again. So here we have a decimal, and we're going to get it between the first two digits, between 1 and 9 here. So we come over and we're going to move 2 hops. And since it's a decimal and we're moving to the right, that means it's going to be a negative exponent. So that's going to be a negative 2. So we're going to have 5 and 273 thousandths times 10 to the negative 2. Okay, you try 8, 9, and 10 on your own and see how you do. Okay, I'm going to move on, so hit pause if you need more time because I'm getting ready to reveal the answer. Okay, here I moved it between the 1 and the 4, and I went to the right 6 places, so that's going to be a negative 6. Here, I moved it over 1 place, but I went to the right, so that's going to be a negative 1. And here, this is where we need this, because this is a very tough number to say, but it's a whole lot easier when we break it down into scientific notation. Okay, what I'd like for you to do is hit pause, and I'd like for you to try 11, 12, 13, and 14 on your own. Okay, so determine if the number is correctly written in scientific notation. If it is not, I would like for you to correct it. So hit pause, and when you're ready, come back and see how you did. Okay, looking at 2 and 98 hundredths times 10 to the 7th power, is that correctly written? If you said yes, you are correct. Okay, let's look at 11 and 4 tenths times 10 to the 3rd. Is that correctly written? If you said no, you've got an eagle eye, because here that decimal has to go between the 1 and the 1. And you also have to add 1 to the exponent to make that change. Okay, what about number 13? 85 and 1/10 times 10 to the negative 5th. If you said no, you are correct, because it has to move over between the 8 and the 5, and you have to take one of your, here since you're moving it, you also have to change your exponent, so it's going to be a negative 4. What about number 14? What do you think? I think that is correct. So how did you do? Now let's work backwards. So I'm going to give it to you in scientific notation, and I'm going to see if you can put it in standard form. Okay, so here we have a positive exponent, which means that we are going to move our decimal to the right. So we are going to have 6,380. Okay, here we're going to move our decimal 5 places, but we only have 3 spots. So what do we do there? If you said add more zeros, you are correct. So it's going to be 208,500. Okay, I'd like for you to hit pause and go down and work through 19. When you're finished, come back and I'll reveal the answer. Okay, for 17, did you get 98 and 2/10? 18, I got 5,388,000. And for 19, I got 821. Okay, now let's go to negative exponents. So with negative exponents, if we have 5 and 25 hundredths, if it's a negative, we're going to move that decimal to the left, okay? And it's going to make it a large decimal. Okay, so here, when we do that, we have 1, 2, 3, 4, 5. So that's going to be a very small number. Okay, let's do the same with this. So here we have 7 and 932 tenths, hundredths, thousandths, and we're going to move it 1 place. So that's going to make it 7,932 10,000ths. Okay, I'd like for you to try 22 through 24. So hit pause, you give it a try, see how you do. Okay, so for 22, we have lots of zeros going on there. For 23, we even have more zeros. And 24 is kind of doable. All right, so how did you do? Okay, now we've got to compare our numbers. So we have two numbers written in scientific notation, and we're going to figure out which one is the bigger one. So pause your screen for a minute and see if you can do 25 through 28 on your own, and then see how you did. Okay, for 25, I had less than. How did you do? Okay, just to remember, the the arrow is pointing to the smaller number. Okay, so it's pointing to the smaller number. All right, for 26, I had that this one right here is the smaller one, and this one's greater. For 27, I have this one is greater. And 28, I have this one is less than. Now let's apply this. Where do we use this? Okay, most of the time it is used in science, hence the name scientific notation. Okay, so here we have the length of a cycle of a visible light wave is that many seconds. That's a very small number. Write this number in scientific notation. Well, easy enough, we can do that. So we have to get this decimal clear over here. So count and see if you can figure out how to do it. Hit pause, give that a try, and then come back. Okay, so I said that it had to go 15 spaces and it had to go to the right, so therefore it's going to be a negative 15. Number 30, the distance from the Earth to the Sun is 9 3/10 times 10 to the 7th miles. The distance from Mars to the Sun is 2 2800 times 10 to the 8th miles. Which planet is closer and by how many miles? Give your answer in scientific notation. Okay, so hit pause and see if you can do this. Now this one is one that is, really using it. So I'm hoping that maybe you can at least give it a try. Make sure you use pencil. You can always erase. So hit pause, come back when you're done. Okay, so I said Earth is going to be closer by 1 3500 times 10 to the 8th power miles. How did you do? All right, so this is a little bit about scientific notation. Looks overwhelming, but it's actually super easy.